Hi guys, I wanted to talk to you about this problem right here, problem 913, as you requested. Before I start, I want to tell you that problem 910, it has something to do with integrating formulas, and it's just calculus concepts. So what I'm going to do is I'm going to just ask you to not worry about 910 right now. Don't worry about it, and we're going to address it again later in the future, because I don't want you to get into calculus concepts right now while we're still just introducing limits. So don't worry about it. Just if you wrote that the answer is d equals 2t, we're good with that. All right. So for this problem right here, 913, the first thing you're gonna do is they ask you to isolate x. So the first thing you want to do is you want to move the denominator to the other side. So I'm going to multiply by root 5 plus root 2, and I get this. So now I have the denominator multiplied to the other side, and I can distribute the 3, and I get that. Make sure that you don't multiply the number with the number inside the root. They're not the same. One of them has a root and one doesn't. Then subtract the root 5, and you get 3 root 5 plus 3 root 2 minus root 5, and since that root 5 right here, 3 root 5, and that's 1 root 5, they're like terms, you can combine them. So 3 minus 1 is 2 root 5 plus 3 root 2. Alright, let's move on to next problem. For problem number 917, it asks you to enter the data in the calculator and create a plot of the data. I am aware that not all of us have a graphing calculator, so in that case, I'm going to show you how to do it manually. But in class, if you want to ask me how to graph on the calculator, that's fine. I can help you in class more on that. Alright, let's look at the graph. Okay, looking at a graph, I just plotted the points manually on a piece of paper. That last number is 37, and the reason I did time in years like that because I wanted to start with 0. It's supposed to be, I wanted it to be here, but that's fine. I just want you to see. So this is 0, 12.51. So the year 1970, instead of saying 1970, I said 0. So that means that the year 1973 is just 3 years after. The year 2007 is just 37 years after. So you see how that worked? So I did the time in years like that. So it's easier for you to see. Alright, so looking at the points, you see that they're almost in a straight line. They're almost linear, but they're not. They're kind of scattered around. So the good thing is if you have a graphing calculator, it's a good investment to buy that, because the calculator has something to calculate the best fit line, or the best line fit that would be exactly in the middle of between all of these points. However, we can definitely calculate it by taking just points that are further away from each other and getting the slope with that. So if I do the last point and the first point, get the slope by using those points, I'll get 0.2224. And then if I do the those 2 points, so the second point and then the second to last, I'm gonna get 0.2203. So what I'm trying to do is I'm trying to find a line that best fits the graph, exactly in the middle, passing through the most points. So I see that if I do that, I'm getting 0.22 in either scenarios. So that's good enough. So if you say, okay, the slope is 0.22, that's good enough. Okay, now since the slope is 0.22, we can say, okay, so the equation is 0.22x plus b. So let's calculate b. If we use the years as I did in my graph as 0, 1, 2, 3 instead of 1970, 1971, 1972. So if I do the years like I did in my graph, not in actual years, but in starting 0 and making 1970 equal year 0, then your b, if you put that the x here represents the time, so if you put x as 0 and use the point 0 and 12.51, then your b is 12.51. So your equation is y equals 0.22x plus 12.51. But the graph that they gave us, or actually the data that they gave us, actually have years written like 1970, 1973, all of that. So I think it would be best to get an equation that represents the years as they gave it to you. So they didn't say the year 0, the year 73, or 37, the year 20. Like, they didn't say that. They said the year 1970, the year 1973. So to get the equation, you need to look at the real point, the original point, 1970, where the population is 12.51, and then get an equation for that, which in that case, it will differ from this equation. So let's work it out. Let's plug in 1970 for x and 12.51 for y and find an equation. So by plugging those values in, I'm solving for my new b, which won't be 12.51 anymore. It would be different. So I plugged in 1970 for x and 12.51 for y, and then when you solve for b, you'll get negative 420.89, and that's your new equation. The slope, which we figured out, is 0.22, and my b is negative 420.89. So again, if we look in the packet, you'll find that the answers are a little bit off, a little bit different, but that's fine because they use a graphing calculator to do the linear regression. So again, I can show you that in class, but that doesn't mean that you can do it manually. So I wanted to show you that even if you see something like that on a test or something, that you can still do it. You don't have to worry about, okay, I don't have a graphing calculator right now. But if you do have a graphing calculator, that would be just more accurate, the answers that you'll get. Alright, so let's look at the next problem, or the next question. So we're still 917. So if the equation is y equals 0.22x minus 420.89, they're asking us what would the population be in year 2020. So again, the x represents the time. So if we look back at the graph, you'll see that the time is the x-axis. So now if I plug 2020 here, what would I get? By doing that, you'll find that the population is 23.5 million people. So again, in the packet is 23.9, just because they used the equation that they figured out using the graphing calculator. However, we didn't do that, so that's fine, that's good enough. As long as you show work and you are doing it correctly, then you're fine. Now, the other thing is, let's say I use the equation that has 12.51 here, then make sure if you use that equation that we figured out instead of this one. So if you use the equation that had 0.22x minus or plus 12.51, that for x you plug in a correct value, which is 50, right? So if you do, okay, so I'm going to plug 50, I'm using my calculator right now, saying 0.22 times 50, because the year 2020 will represent 50 if I used the equation that had the year 1970 equals 0 and all of that. So if I do that on my calculator, I'm doing it right now, and I'm getting 23.51. So you'll get the same answer in either equation. Just make sure that this equation right here, we use the point 1970 and 12.51 to get this b value, and the other equation had 0.22x plus 12.51 as my b value, but the x represented time in years, starting 0 as the year 1970 and going to 37 as the year 2007. Yeah, so make sure that you use the correct equation and input the correct time. Alright, so for C, they're asking you to find the average rate of growth between the year 1970 and the year 1999. And they gave you the formula. They said the change in population over the change in time. So what I did is I did the change in population for the year 1999, where the population was 18.94, over the change in, with the other point, which is 1970, and where the population is 12.51. So change of population on top over the change of time, as they said, and I got 0.2217. Now that's 2.2217 million people, right? Because they gave us in the table that the population is in millions, and you'll see in the table that under the word population it says millions, right? So 0.2217 and then more decimals million people. So now I don't want million anymore. I can multiply and say, okay, so I can do 0.2217 times a million, because it's 0.2217 million. So if you do that multiplication, you'll get 221700, which is great. We got the right answer. So let's look at D. If we look at D, you'll find it the same thing as C. So if you're able to do C, you'll be able to do D. So you can try that. I am running out of time on the video, so C and D are exactly the same. So you can do D on your own. When is the growth increasing most rapidly? So in that one, which is question E, we can refer back to the graph to check when is the population really increasing by that much, like really a lot. Or you can look at the data and decide, okay, well, between the year, for example, 1977 and the year 1981, that's only increasing by 0.5 million people. So you can compare each interval by looking at the graph. You'll figure out that this area right here has a rapid increase in population. Like, people are increasing a lot. Like, you see, between this year and this year, there is just not much change. In the middle, it took a long time to increase. Here is also a longer time. Here took a long time to increase, but now here the kind of population kept increasing real fast, and then it kind of slowed down again. So we can say by looking at the graph that between the year 1986 and the year 2002, in that area, the population is increasing really rapidly. And then you can check on each interval to see which interval has a higher or the highest change in population. So you can get the slope between those 2 points, between those 2 points, between those 2 points, and between those 2 points to determine which one has the highest change. But then if you tell me that's between 1986 and 2002 based on my graph, I will accept that as an answer as well. So this problem is good because it's open to interpretations, and you can do it manually. It's very interesting. Well, I hope that helps, and I'll do another video for the next problems. All right, thanks.